the series converges or diverges. If it converges, determine its sum. So we got two terms. Oh, they are almost same. E raised to 1 over n minus e raised to 1 over n plus 1. 1 over n, 1 over n plus 1. Almost same. Okay. So here let's find the nth partial sum, because we want to look at first couple of terms. Okay, then from there we might be able to see what the sum would be. Okay, this is a telescoping series because we have almost same as a negative sign. So when we take n equals 1, so if we take n equals 1, that's the S1 sum of first term, just 1. That would be e raised to 1 over 1 minus e raised to 1 over 2. Okay, e raised to 1 over 1 is just e minus 1/2 e. Okay, if we take n equals 2, then we get sum of first two terms. So in this way, we're going to get to Sn, where n is, because we are supposed to add infinitely many terms, which is not possible. So we go up to n. Okay, n is any generic number. And then we let n go infinity. And this limit, if this limit is a finite number, then we say the series converges and the sum will be that finite number. To write down nth partial sum, so I'm just trying to write down a couple of terms. From there, I'll be able to write Sn. So S2 means when we take n equals, S2 means n equals 1 and 2, so two terms. Okay. So n equals 1 will be this, so e minus e raised to 1/2. Now we are taking n equals 2. S2 means sum of first two terms. Okay, 2 means e raised to 1/2 minus e raised to 1 over 2 plus 1, 1/3. Okay, and how about S3? I'll be writing three terms. So these are first two terms. So e first, second, and the third term would be n equals 3. So e raised to 1/3 minus e raised to 1/4. Okay, so in this way, what is nth, where n is any generic number? So we have first term, I mean sum of first n many terms. So first term would be this, second plus third, and fifth, fourth, okay, fifth, okay, all the way to, let me write down nth. So this is for n equals 1, n equals 2, n equals 3. Now I'm going to go to n equals n, okay, the last in this case. So we are taking first n many terms. That would be then here e raised to 1 over n, because the little n is uppercase n, okay, minus e raised to 1 over n plus 1. If we look at closely here, 1 over n and 1 over n plus 1, I mean there is one difference, okay, on the bottom. So we can just write one last term. If there is a jump of 2, then it's better to write two last terms so that we can see what terms cancel. Okay, so after we write sum of first n terms, okay, there will be some cancellations. You can clearly see here e raised to 1/2 negative is a positive e raised to 1/2 cancel, e 1/3 cancel. We did not write the fourth term, otherwise this would cancel, and all the way to this would cancel. Okay, the second last term would be this one. Then we would have just the first term e raised to 1 or e, and the very last negative e raised to 1 over n plus 1. And since 1 over n and 1 over n plus 1, there is a jump of 1, that means eventually just one, very first term and very last term, one and one last term survive. That's the sum of nth partial sum. Now we take the limit n infinity of Sn, so that means limit here, so e raised to 1, okay, just e. When we take the limit, e is just e minus, okay, 1 over infinity. 1 over infinity is 0, so e raised to 0, okay, when n goes to infinity. Okay, and we know that e raised to 0 is 1, so e, that's about 2.7 minus 1. Okay, so the sum, this is a finite number, that means the series converges because we got the limit as a finite number, and the sum is e minus 1, okay, about 2.7 minus 1, final.